In this video, we are going to discuss a few different relationships between angles and triangles, including interior and exterior angles. The sum of interior angles of a triangle is equal to 180 degrees. Interior means the inside of the triangle, and sum means adding all of those angles up. We can easily find missing angles in a triangle using this property. One symbol used oftentimes in a triangle is this symbol you see here. When you see this symbol, that means that is a right angle. A right angle is always equal to 90 degrees. So if you see that box symbol in a picture, it is meaning a 90-degree angle. So in this triangle, I can set all my angles equal to 180 degrees. So I have angle C plus 90 degrees plus 25 degrees is equal to 180. Then I can use my previous skills of solving an equation by combining like terms of both numbers. So I have C plus 115 equals 180, and then using inverse operations to solve out for that missing angle, and I will discover that missing angle C is equal to 65 degrees. I can use this same process by finding the missing angle in this triangle on the right, setting each of these three angles equal to 180. This time, my missing angle is equal to an algebraic expression of 3x. I can still use the same process of solving this equation to discover what this angle is equal to. First, I will combine my like terms of my two numbers, and this will give me a resulting equation of 120 plus 3x is equal to 180. Then using inverse operations to solve out for x. Once I find x, I have not found the missing angle because as you can see in the picture above that the missing angle is not just x, the missing angle is 3x. So then I need to substitute this angle back into that algebraic expression to find out what that missing angle is equal to. 3x is telling me to take 3 times the value of x, which we discovered to be 20. So that means that this missing angle is equal to 60 degrees. We don't necessarily need a picture to discover missing angles in triangles. Knowing that in this statement we are finding a missing angle in a triangle, we can set all of these three angles equal to 180 degrees because the sum of all interior angles in a triangle is equal to 180 degrees. Once again, I can solve this equation by first combining my like terms of all three numbers, and then using inverse operations to discover that x is equal to 5. But once again, my missing angle is not equal to just 5. It is equal to the x value plus 10. So I need to take this value and plug it into that algebraic expression to discover that missing angle will be equal to 15 degrees. A couple more similar angles, once again, always still following that process of setting all of my angles interior of the triangle equal to 180. In this example, I am able to combine like terms of x terms. I've discovered by solving this equation for x that x is equal to 20. Once again, each of these angles have a different algebraic expression, so I need to substitute that x value into each of them. This missing angle is just x, so it is simply 20 degrees. The bottom right missing angle is 3 times the value of x, so 3 times 20, or 60 degrees. And the bottom left angle is 5 times the value of x, or 100, so it is 100 degrees. I can always check my answer on any of these questions by adding up all the three values to ensure that they are adding up to 180 degrees, which is in fact true in this example. 100 plus 20 is 120 plus 60 is in fact 180 degrees. In this next example, I have x terms and numbers in my equation for each of those values of those missing angles. So I can combine my x terms and I also can combine my numbers in this equation. Remember, I'm not using opposite operations because they are on the same side of the equal sign. They are a part of the same expression. And then I have two inverse operations to solve for x, and I discover that x is equal to 21. Once again, then I need to take this value and plug it back into each of these expressions to discover the missing angles. The top left angle is just equal to the value of x, so it is equal to simply 21 degrees. The top right angle is equal to the value of x plus 2, or 23 degrees. And the bottom angle is equal to 6 times the value of x plus 10. 6 times the value of x is 126, plus 10 would give me 136 degrees. Exterior angles are on the exterior of the triangle, or the outside of the triangle. These are formed by one side of the polygon and an extension of an adjacent side. Adjacent means next to. So in this triangle, you can see through the dashed line, which is an extension of one side of the triangle next to that exterior angle. Together, angle 4 and angle 3 create a linear pair. These two are also known as supplementary pairs because they create an angle of 180 degrees. In this diagram, angle 4 is the exterior angle. It is on the outside of the triangle. Angles 1, 2, and 3 are interior angles of this triangle. If the measure of angle 3 is 60 degrees, I can find the measurement of angle 4 by creating a supplementary pair. Remember, supplementary angles are equal to 180 degrees. Think of that dashed red line creating half a circle, and half a circle is 180 degrees. So to find angle 4, I can set up an equation of 60 plus the measurement of angle 4 is equal to 180 degrees. So I can subtract the measurement of angle 3 from 180 degrees to discover that angle 4 is equal to 20 degrees. 120 degrees. The exterior angle theorem states that the measure of an exterior angle of a triangle is equal to the sum of two non-adjacent interior angles. So as I look at this diagram, angle D is an exterior angle. It's on the outside of the triangle. Angles A and B are two non-adjacent interior angles. Non-adjacent means they are not next to that exterior angle. This red angle would be an adjacent interior angle to angle D. It is right next to that angle D. A and B are two opposite interior angles. They are non-adjacent and not next to angle D. One thing that is true about any exterior angle in a triangle is that it is equal to the sum of the two non-adjacent interior angles. So angle D is equal to the measurement of angle A plus the measurement of angle B. I can use that property to help me find the measurements of missing exterior angles. For example, to find the measurement of angle N in this diagram, I can simply add the measurements of the two non-adjacent interior angles and discover that the measurement of angle N is 113 degrees. I could also find the measurement of angle N by seeing that it creates a supplementary pair with the 67-degree angle, which would also give me an answer of 113 degrees. To find the measurement of angle X, I will also add together the two non-adjacent interior angles to discover the measurement of my exterior angle X to be 109 degrees. In this example, we are not given a picture, but sometimes it is very helpful to create a picture to visualize what type of triangle we are creating. It states that David draws a triangle with one angle that has a measurement of 60 degrees. So that can be any angle in our triangle. I will place it here. It asks what is the measure of the angle's adjacent exterior angle. Remember, adjacent means next to, so that could be this angle right here because that is next to it and on the exterior of the triangle. That could also be placed going this direction in my triangle. That is also on the exterior and adjacent to that triangle. So extending one side of my triangle and finding the exterior angle, I simply can find that exterior angle by creating a supplementary pair. That exterior gray angle and the 60-degree angle will be equal to 180 degrees. So subtracting 60 degrees from 180 will give me the value of that exterior angle. That also means that the sum of my two non-adjacent interior angles is also equal to 120 degrees.